Orthopedic wearable with infrared light to stimulate bone healing, team number 37. Julia Burke, University of Massachusetts Amherst, Alyssa Giordani, University of Delaware, Nicole Dressler, Worcester Polytechnic Institute, Ashna Patel, Rutgers University. Our goal is to create a solution to treat wrist fractures of children ages 4 to 12 years in Brazil using low-level light therapy. Low-level light therapy works to deliver a specific light wavelength to the cell to promote wound healing. We're using a red light with 630 to 640 nanometers wavelength to target the cells of the wrist tissue. Those wavelengths maximize cell stimulation and depth so the laser can reach through each type of tissue. The light reaches the photosensitive mitochondrial chromophores in the cell's mitochondria to increase its production of ATP, which is the cell's energy. More ATP means more energy for the cell to use for healing.
The design that we made was created in SolidWorks. Our solution would be that we would create a cast that is able to be 3D printed. The base models can be edited by an orthopedic, or they can use a standardized size options that we would create. The cast will come in two pieces that are connected using a male-female sliding mechanism for simplicity that a child or parent can remove if needed. When they are ready for the infrared therapy, they can plug in the lights to any outlet or charger for 20 minutes and then unplug it and continue with their daily life without disturbing the cast. For the design process, we started by finding some base measurements. Since none of us are within the age range that the cast is designed for, we don't have access to anyone within that age range. We used our own measurements, specifically mine. The original SolidWorks file started off as a cylinder being one piece before hollowing out the center. Once we had one symmetrical cylinder-like shape, we're able to create openings that allow the arm to receive air and created trench-like indents to house LED lights. The next step was to separate the two sides and begin working on them separately. The main challenge was creating the calculations and finding the measurements for the male-female sliding attachment. We first worked on the female top side and determined the measurements before continuing on the bottom male side. The final step was going into the assembly and making sure that everything fit properly.
In order to create our design, we will need a few materials. Most importantly, we will need a 3D printer. We chose a stereolithography printer because the printer has a low tolerance level, meaning it will print a more precise cast than other printers. Stereolithography printers also make it easy to add exterior designs on a product, which may be exciting for the children receiving the cast. Lastly, stereolithography printers will print with more smooth exteriors and don't use as much material as other printers, hopefully keeping the cost low. The printers we looked at will be approximately $11,000 to $13,000 based on the size of the printer. The material we decided to put into the printers, i.e. the material the cast will be made out of, is a plastic called acrylonitrile butadiene styrene. This plastic is the ideal material because it is cheap and durable. It is also waterproof and temperature resistant so that the cast will not limit the wearer's actions as much as a normal cast does. On average, a 750-gram roll of ABS will cost about $70. In addition to these materials, we will also need infrared light strips, which will cost approximately $70 for a 500 centimeter length. Lastly, we may need cotton liner to pad the cast, but as most hospitals carry that material already, we anticipate that cost to be negligible.
In designing our orthopedic wearable device, we chose to focus our efforts in the country of Brazil. For medical devices, the Brazilian regulatory body is known as the Brazilian National Health Surveillance Agency, otherwise known as Anvisa. Anvisa reviews applications, ensures quality, and enforces safety standards. According to Anvisa, a medical device is something used to diagnose, prevent, monitor, or alleviate a disease, as does our product. Medical devices are classified by the amount of risk they pose to the body. This is based on three criteria: duration of contact with the body, degree of invasiveness, and local versus systemic effect. Considering our product poses little risk to patients, is minimally invasive, and relatively uncomplicated, it falls into the category of a Class 1 device and is safe for approval according to Brazilian medical device regulations.
Thank you.